Have you ever wondered what's really going on inside your phone, or your laptop, or even the dashboard in your car? We're living in this invisible world of electronics, and today we're going to peel back the cover and take a look at the one component that makes all of it possible.
Okay, so picture your smartphone as if it were a person. All those little chips and resistors, those are its organs. The electricity is the blood flowing through its veins, and of course, the case is its skin. So, what's the nervous system? What's the thing that connects it all together and tells every part what to do?
Well, that nervous system is the printed circuit board, or PCB for short. It's the skeleton, it's the foundation, and it's the communication network all rolled into one. It's the hidden hero that brings a sense of order to the incredibly complex world inside our devices. But you know, it wasn't always this organized.
To really appreciate just how elegant a modern PCB is, we have to go back in time. Back to an era of, well, total electronic chaos. Before we had the printed circuit, building even a simple device was a tangled, painstaking mess. I mean, seriously, just imagine a rat's nest of wires. Engineers had to manually cut, strip, and solder every single connection, one at a time from one point to the next. It was incredibly slow, it was full of potential errors, and if something went wrong, good luck finding it. It was an absolute nightmare to troubleshoot. And this right here says it all. On the left, you've got that hand-wired mess we were just talking about. And on the right, you see the clean, structured, and unbelievably dense layout of a modern PCB. This leap, from total chaos to perfect order, is what made our modern world of technology possible.
So, how did we make that jump? How did we get from that tangled mess to the clean boards we have today? Well, the answer, like with so many great inventions, was born out of necessity. Industries like aviation and medicine desperately needed smaller, more reliable electronics, which forced engineers to find a much better way.
And that solution was the printed circuit board. The idea is kind of brilliant in its simplicity. Instead of a mess of wires, you essentially print all the connections as copper pathways directly onto a rigid, non-conductive board. This single innovation gives you both the physical structure to hold everything and the electrical wiring to connect everything.
And the benefits of this are huge, and they all build on each other. So first up is size, miniaturization. By printing the connections, you can pack components incredibly close together. This is literally how we went from computers that took up an entire room to ones that fit right in our pockets.
And when things do go wrong in these tiny devices, repairs became way simpler. PCBs are often printed with labels for every component, kind of like a roadmap. A technician can quickly spot a faulty part, remove it, and just solder in a new one. This simplicity was a complete game changer for manufacturing, too. Once a board is designed, you can just use automated machines to pump out thousands or even millions of perfect copies. It sped up assembly like you wouldn't believe.
All those components are also way more robust. Everything is soldered firmly in place. That means no loose wires jiggling free, which is absolutely crucial for any device that moves around, like, your phone in your pocket or all the electronics inside a car. So the key point here is that these printed copper tracks create incredibly strong connections. A hand-soldered wire can get brittle and break over time. These pathways, they're literally part of the board itself. They aren't going anywhere.
Okay, this one's a little more technical, but it's super important. Think of electricity as a conversation. In that old jumble of wires, it was like trying to talk in a loud, crowded room. You get a lot of interference or noise. A well-organized PCB creates short, direct paths. It's like having a crystal-clear phone line for those signals, which prevents errors and keeps the device running smoothly.
And of course, what does all of this lead to? A lower price for you and me. Because they're so easy and cheap to mass produce, PCBs have made complex electronics affordable for everyone. They're the reason powerful technology isn't just for big corporations anymore.
So when you add all these things together, the strong connections, the clear signals, the precision manufacturing, you get one ultimate advantage: reliability. Devices built on PCBs just last longer and work better, plain and simple.
But, not all PCBs are created equal. Just as our technology has gotten more complex, the boards themselves have evolved into different shapes and forms for different jobs. So let's take a quick tour of the main types you'll see out there.
We're looking at 6 main categories, and each one kind of builds on the last. We'll start with the simplest and work our way up to the really advanced stuff. First up is the single-sided board. This is the most basic type there is, with all the copper tracks on just one side of the board. Now, because the electrical pads can't cross over each other, it's really best for simple, cheap electronics, like a basic calculator, where you're not trying to do anything too fancy. And here's a classic example. The components would be mounted on the other side, the smooth side. And all the wiring, all those little copper traces are right here, visible on this side.
But what happens when your circuit is too complex for just one side? Well, you can add a layer of copper to the other side. That gets you a double-sided board. And for really complex devices like a smartphone or computer, you can actually stack multiple layers together like a sandwich, creating this 3D highway of connections. That's how you cram something so powerful into such a small space.
Now, besides the number of layers, there's another big difference: the form factor. Most PCBs are rigid. They don't bend at all. But some are made on a flexible material, almost like a thin ribbon. This lets them bend and twist to fit into really tight or weirdly shaped spaces, like inside a modern digital camera.
And finally, you can combine the two and get the best of both worlds. These are called rigid flex boards. They have stiff sections for mounting the important components, and those sections are connected by flexible ribbons that act like built-in cables. These are perfect for really high-performance stuff, like in aerospace or advanced medical gear, where you need both stability and the ability to fit into a complex shape.
So, from that chaotic nest of early electronics to the sophisticated, multi-layered, flexible boards of today, the PCB has been the unsung hero that's been driving technology forward. It's the invisible architecture holding together pretty much every piece of our digital lives.
Every single digital tool we use, including the one you're using to watch this right now, relies on one of these boards. And they're constantly getting smaller, faster, and more complex. So the next time you pick up your phone, just think about that hidden world inside. The real question is, as these tiny nervous systems keep evolving, what amazing new abilities will the next generation unlock?